Okay, so once again, I did not put grades on these because I don't want you to focus on the grade. I want you to focus on what we need to learn out of this. Okay, so quick questions that we have: do you subtract the two z-scores to find the area? No, you do not subtract the two z-scores. You find your z-scores. By the way, what is a z-score? I was going to talk about this a little bit later, but what's a z-score? So, number of standard deviations. The value is either above or below the mean, from the mean, right? By the way, Jaden, if you want, you can turn the desk so you can see more easily. But one thing I want to point out about this is, I don't know that I talked about this detail with it clearly enough, and I want to address it now. So if the z-score is identifying how many standard deviations from the mean, it's also a location. Let me say that one more time. A z-score is a location inside the distribution, just like a percentile is. When we say the 30th percentile, that means 30% of the scores are less, right? But that's a location. The percentile is a location. The z-score is also just a location inside of my distribution. If the z is negative 1.2, it's just a location telling me that that original value was 1.2 standard deviations below the mean. If I have a z-score of 1.7, that just tells me that the value is 1.7 standard deviations above the mean. When I go to that calculator to get the area, I put in the lower bound, I put in the upper bound, I don't subtract them. Those are the bounds. The calculator does the work for me from there. There's that question. I don't know what that says about 5%. Yes, Serena.
On 15A, was there no range? Because
We'll get into those in a second. I'm just answering these questions. Okay, practice problems on z-scores, or which notes should I look at? So I gave I'll go back through and look at the exact ones, but the z-score stuff started with mathematic. I think it'd be like 2.4, 2.5 maybe. If you look at the back, it says it there. There's also several skew the script things that go with z-scores. Correct me if I'm wrong. Actually, let's just check. I believe I opened up an AP classroom assignment also associated
Wait,
with
which did you say is z-scores?
2.5, 2.6 I think. It's the one that starts with talking about Ed Sheeran. It says Ed Sheeran and Taylor Swift at the top.
The packet.
Yes, it's inside the packet. Yep. So that's where z-scores first started showing up.
Which video?
Actually,
with that?
I lied. Sorry.
Oh.
Let me go back. Z-scores were actually originally in 2.2. Using z-scores in normal distributions was the Ed Sheeran Taylor Swift.
Which video is that? On the YouTubes?
On the YouTubes.
On the YouTubes.
Let's see. So I've got a playlist there. Unit 2, exploring one variable data. So remember, I have it separated as playlist, and if you look, so here on February 4th is the empirical rule, normal distribution percentile. The 5th has percentiles and z-scores. So February 5th, and February 6th, and February 7th. So February's 5th through 7th have a lot of that. But again, if you just go look at the titles, I have it labeled in there. Apparently I forgot to label.
they are in order. It makes me mad.
Yeah, why are they not in order?
I don't control that. No, I'm serious. I'm not being a punk about it. It's I don't know why it randomly does that. But again, if you go to the playlist, oh, it is in there. I don't know why it wasn't showing up. If you go to the playlist, I try to make sure it's in the playlist every time.
Okay, YouTuber.
You didn't see my notes.
Right? Hey, I subscribe to you on YouTube.
Did you?
Yeah, it's gonna be famous one day.
We're gonna give you a silver play button like Mr. Mac has. You just need to post videos of yourself with a wig and a bathtub.
No, have you seen his
You need to
actual
go for
TikTok?
remake.
Huh?
Have you seen his actual TikTok?
Weren't they testing anal drugs in China?
What?
And he had a pink wig?
Yeah. No, there are all kinds of stuff.
He was testing the anal wig and he was testing.
Hello?
that's why.
Can we stop?
You said what? No. Don't make
pull
him
the
say it
photo.
again.
You know, he followed Austin on
Alright,
TikTok.
I'll
and
go
then he
back.
found
Anyways,
Austin
guys,
Community account.
statistics.
Okay,
Statistics.
27.
Okay.
Anal method of vagina.
It'll be those videos. I'm gonna make sure the thing, whatever, updated the playlist. Oh, that's what I was gonna try to show y'all. Let me check. I think that I have an AAP classroom assignment that you don't have to do, but if you're struggling with Z-scores, is probably a good one to do. While that's loading, let's make sure I do attendance so I don't get yelled at later. Let me know if you're not here.
Huh?
Did you write on the board?
I don't
Right
think
on
I'm
the
here.
board. Oh no, that was me.
There's only one person that writes.
I don't know what you're talking about.
Okay.
Yeah.
Okay.
It looks really similar.
I didn't like it.
Yeah, I must have a twin.
No,
You must have
no,
a twin
no,
in your
remember
handwriting.
your siblings in like
Okay.
the backyard?
Huh?
Yeah, so I have
They're
it
actually in the front
right here.
yard.
Hey guys, right here, if you want it, so I need to go in and shoot me an email if you do this, because apparently I have to click on this and score it. But there are these percentiles and normal distribution practice problems. So if you need that extra practice, it's there in AP Classroom. But again, I have to score it because that one pre-response question. So shoot me an email so you can see your responses, because you were able to see your responses, right?
Yeah.
Okay.
Wait, have you done our proficiency skills yet?
No.
Brother.
It's like a
Listen,
really big
listen, I will get there. I promise you. This weekend, maybe even tonight, it will happen. However, right now, we gotta focus on learning. So, agenda, no wait, did I answer those questions? Yes. We're gonna get into probability later today, but right now we're gonna do a DYU analysis and talk about it. I'm gonna go over, actually I already went over the AP Classroom questions yesterday, right? Yes. So DYU is today. Okay. I think for the most part we're pretty good here. Just remember when we standardize, we add and we subtract, we multiply and we divide. What does that not change though? Or let's say it this way, multiplication affects what in a distribution? Spread and center, right? Multiplying, dividing affects the spread and the center. Adding and subtracting affects the center, which is why this one was not 11, it was 12. But what does standardizing not affect whatsoever? Shape. The z-scores as well, because the z-score is part of that transformation, but it doesn't change the shape of the distribution. Be careful with your quartiles. What's the wrong with that word right there?
And in, not at.
It is always at a percentile.
Jake, your butt shot.
Make sure that you are saying at a percentile.
Or the sea crack.
I think,
Why would? That was funny. That was funny.
okay, really quickly, Michael, what's the empirical rule?
67.
No! 68!
68, yeah, I got that.
95.
99.7.
99.7. Those are three you gotta know. So notice, number 4 says less than 2 standard deviations below the mean. So from here to here, I'm just making that up. That's from -2 to 2. What percent of my data is in between -2 and 2? 95%. So what is the combination of the two tails, everything outside?
What?
Total, there's 5%, right? Which that's what that says, 5%. But I'm only talking about what is less than 2 below. So that's not the full 5%, that is only
That's a
2.5%.
confusing question.
Sorry, that's how it's worded on the AP, that is what it is. We need to be careful about that. Like, what would have made that more clear?
Not saying it's 2 standard deviations, saying less than 3 standard deviations.
But it's not less than 3. Less than 3 would have only been 0.015% because it would have only been this. I want what is at 2 or below. So that's why I said less than.
Ain't no way that Jane Dow got an E for saying just 2.5 and no explanation.
Yeah, that's actually a good
Mistakes may have happened. What?
I also got E, and all I said is that I changed 5 to 95, and I changed less to within. I said 5% is
Yeah,
the
did I give you a P on that? Not?
No.
Oh, an E? I was very generous then, because I remember debating a P or an E.
Let's leave it an E.
Because your ideas are right that it was 95%, but the main thing is I want us to recognize only 2.5% in that tail. Yes, ma'am.
2.
I have no clue what's your question?
2, is it because shape doesn't, you can't standardize shape?
So standardizing involves adding, subtracting, multiplying, dividing every number by something, okay? So when we standardize, it affects the center, it affects the
doesn't
spread,
affect shape.
it does not change the shape.
What is need to see lesson on transforming distributions? Which one is that?
It is labeled in the video.
I hate the video. Oh god.
It's like the one that, it's like February, it's the one that we were supposed to watch because we weren't here.
6 and 7?
It was a 6th
Something
one.
like that, yeah.
Okay.
It's somewhere in the 5th to 7th
I have
range.
to watch.
I will say this, yeah, it's in there. And it's one of the early
It's
mathematic lessons.
not.
Alright, once again, why were we not able to know the z-score for the third quartile here?
Because it doesn't give any like
Yeah,
units
It
or.
was not symmetric.
This is not.
If it was approximately normal, could I find it?
Yeah.
Sure, not just sure, yes, like, how would I find it if it was approximately normal?
Calculator 0.75.
Right, so remember, if it was approximately normal, the third quartile means that we're at what percentile?
75th.
75th, right? The third quartile would be in the 75th percentile, and I do inverse norm with that 0.75. It's not normal, so I can't do that here, right? So keep that in mind. That would be an area of 0.75 for that percentile. I think we're pretty good on number 6. For the most part, we're pretty good on 7 and 8. Do I need to talk about 7 or 8?
I don't understand. 7, like, I don't understand the question.
Okay, well, notice right here, it says, so we have all this data, right?
Yeah.
Data. Boop. Those are all summary statistics, by the way. But it tells us that one of the years, the standardized number of complaints was z equals 1.4. Well, how do we calculate a z-score?
Oh, value minus mean.
Value minus mean
Value.
divided by
That's
standard
why I was
deviation.
here. See, everyone
My
was
z was 1.4. My value is what I want to know.
all over your glasses.
The mean was 11.916, and my standard deviation was 4.324. And you just solve that equation.
So, value, like, is there a case where they're gonna give me the value?
Yeah.
What,
But you would still, I mean, like,
what does that look like? What is the value in this?
the value is the number of complaints. The answer was 18. 18 complaints was 1.4 standard deviations above the mean. So like, that's how we calculate a z-score, the number of standard deviations above or below the mean. We just plugged everything in. So like, sometimes I'm gonna ask you for the z, and you plug in your value, the mean, and standard deviation. Here, I gave you the z-score, I gave you the mean, I gave you the standard deviation, you plug that in, you find your value,
Okay,
okay?
yeah.
Alright. So birth weights. There are 2 ways you could approach this one. What were they?
You could subtract the z-scores above.
I wouldn't subtract z-scores on this one.
I don't know what I did, but
Okay.
I got it.
I think I just guessed on this one.
So, you could do normal distribution with z-scores,
Yeah,
right?
that's what I meant.
So a mean of 110, a value, 1 standard deviation is what, 15, right?
Yep.
So 125 is 1 standard deviation above the mean, 140 was 2 standard deviations above. So what are the 2 methods I could use here?
Empirical or?
I could use empirical rule, or I could use z-scores, right? Like either one is perfectly fine, so you just do from 1 to 2. And now if you're using empirical rule, there's a nice part of it. It's 2 standard deviations, but how much of that 95% is it? How much of the 95% do I have? Am I looking at the whole thing? No, I'm only looking at half, because I'm only looking at the right half, so
13.5%.
I'm not there yet. I'm asking, if I'm going to from 0 to 2, I'm looking at half of the 95%. But I don't have this piece. So if I don't have something, I gotta take it away. Well, what's that half of?
68.
Well, it's half of 68,
It's 34.
which is 34. 47.5 minus 34 is 13.5.
Wait,
That's
why,
what you get if you use z-scores.
why are we minusing it
So,
from the full 7.5?
Remember, Sprague, when I look right here at that half of 95, that's all of this right here. All of this region. But I don't want all of that region. So I don't want all of the 47.5. I don't want this piece that's not shaded in. I don't want it.
So that's what we're taking away?
So I took away the piece, the half of 68, that I didn't want. Now, if you're uncomfortable with empirical rule, you need to practice with it. Empirical rule can be really helpful. However, you can always use z-scores, right? So you could do this as your lower bound, this as your upper bound, with a mean of 0 and a standard deviation of 1, right? So from 1 to 2. I was a little surprised by how many of us did not like number 10.
What's wrong
Okay.
with number 10?
This one right here. So let's talk about this quickly. Guys, if we know that it's a normal distribution and we see 99.7, what should we immediately think of?
Third standard deviation.
3 standard deviations, right?
Wait, stop.
So from 3 below to 3 above is 5 feet. Y'all good over there? And 7 feet, okay? Hey Jaden, can I get you to come sit with the clean section right here? Thanks. Yeah. So how can I figure out what the standard deviation is? There's 2 main ways. So, I mean, something with the empirical rule-ish, right? We kind of already used that part. Like, what am I going to do from here, though, to figure out what my standard deviation is? Find the mean. Okay, so what is my mean?
6.
6 feet. It's got to be in the middle, right? So now how am I supposed to figure out my standard deviation? Huh?
That would have been so much easier. Dude.
What do we do from here, then?
I mean,
Say again.
What?
How am I going to figure out my standard deviation from here?
Don't you add the 1 and 2?
Say again.
Do you add the 1 and 2?
So I got to do, okay, I can mark the 1.
I solved it like.
I got to mark the 2. But what are these heights so that we get up to 7 foot?
12.
4, 8.
So 6'4", 6'8".
That's how tall I am.
Yeah. Plus another 4 inches gets me 7 feet, right?
No losing ass science.
That's it. Say again.
Yeah.
Never mind.
So it's a standard deviation of 4 inches. I will point this out right here, okay? One thing, I didn't even think about it until just now. Well, one thing you could do is, how far is it from the mean to 3 above the mean?
3 standard deviations.
Yes, 3 standard deviations,
1
but how
foot.
many inches?
12 inches.
12 inches.
So you just
That's
took
what I
out, yeah.
did.
Yeah, that's what I did. I
I did something
That's
way
it.
worse.
like I started
You
finding mean
could
and
also, really quickly, you could have also just said, hey, from 5 feet to 7 feet is how many
then
inches?
24 inches.
24 inches.
And then I divided by
Divided by the
6.
6 standard deviations.
I did.
4 inches.
Yeah, that's what I did.
It's that simple. I always have thought through the mean and then 3, but we need to notice it's from 3 below to 3 above. That's a total of 6 standard deviations.
I did 84 minus 60 divided by 6.
84 minus 6, what?
I did like the number.
You found the total number of inches?
I just divided by 60 because there's 6 deviations.
Yeah, I mean, that's essentially what we did. We just made it easier because we just went from 5 to 7 is 2 feet.
Oh.
Anyways, okay, so we need to talk about this one. This one was the one that got the most people, I think, on the multiple choice.
Like,
Okay?
how do you do this without guessing? Or like process elimination?
Well,
Yeah, that's actually a
Okay,
good question.
Everybody needs a calculator in hand. Everybody needs a calculator in hand, okay? Well, maybe if you weren't distracting me talking,
She
you while I was
stole
trying
my
to
stuff.
teach.
She stole my stuff and was distracting me.
I was fixing it.
Okay, well, regardless
guys
of
are
creating the
both
problem.
distracting
regardless of
me.
who stole from who, I'm fixing it. Let's go. You need a calculator though. Alright, guys, I just want to point this out. When I look at this, I don't know for sure, but I immediately thought inverse normal. What told me I know, like we're not seeing it, but this is, I need us to think through this from now on.
At least.
Why did I think inverse normal?
Oh,
We're
the top
giving at least
15%.
45.
Like, I got an area given to me. I've got an area and I want a value. Okay, if I've got an area and I want a value that is the inverse of our normal direction, normally we go from a value to an area. Now we're going from an area back to a value. So 1, I draw it out. It's multiple choice. I don't care, draw it out. So the top 15%, but when I go inverse normal, I can't put 0.15 in there. What do I need to put in?
0.85.
I need to put the lower piece. So everybody, do inverse normal. Find out what my z-score is, please.
1.03. I would have got it right if I just didn't change the sign.
Have you taken the time to do the inverse normal?
Wait.
Sanaya, Lana,
I didn't
Brayden?
even get that far. I think.
I'm telling you to type it in now.
My bad, I'm sorry. I'm so sorry.
Did you get this right?
So yeah, I'd use
Why
part
did you-
elimination though.
Why what?
I got this right, but I didn't
You just
write
guessed
anything down.
No, I'm trying to well, kind of, yeah. I knew that it couldn't be over 45, so I immediately got out the first 30. Then I was like, this area
Right.
deviation is bigger than
15, so remember, we talked about this at some point, 15% per 100 is
Right, I get
0.15.
So like,
But that's the top end. When I do my inverse normal, it can only do the bottom.
okay, I get it.
Okay?
I got it, I'll be right
Or you could just do part eliminations.
Okay?
Leave it at that.
Now,
This is a standard.
there's my 1.03. But again, how do I calculate my z-score?
Oh, equals x minus mean over standard deviation.
Now remember, if it's a population that I have, what symbol am I going to use
I
here?
like said,
U and here. That's
The
lowercase sigma, right? This sigma. Okay? So, which of these values do we already know?
the standard deviation.
At least 40.
So the standard deviation is 4.9,
everything's backwards.
right?
At least.
What is the 45 though? Is that my value or my mean?
I think I did right. but
That's
it
the
does
what?
say mean.
Value.
That's the value.
I know, but I'm not.
I will point out, and I think Serena was saying this earlier, like, it had to be less than 45, guys. That's above the mean, is it not? And so, if that value's above the mean has to be less, the mean had to have been A or B. No shot at it being above that, right? But how do I solve it? How do I figure it out from here?
Times 4.9.
I just solve it. I use inverses and properties of equality. So, that's 5 point something. Thanks, Jacob. I don't remember, 5.1 maybe?
Thank you.
And you
How do
continue
get that?
solving it. So guys,
How do you-
again, one of the big things
Oh.
here is
Thank
what told me that I wanted to use an inverse normal right away.
Percentage.
I saw a percentage, I saw an area, right? Like I need to convert or think about that percent as an area with a normal distribution. Now, it's not always gonna be that case, so you gotta think through everything, but I have an area and I want a value. Technically, I want the mean, but I still wanted some kind of value from the z-score. So I had to go from area to z-score. I had to use the inverse normal. That's what instantly jumped out at me. Like that's something I would write down is that idea of, hey, we have an area, we need a z-score, so inverse there.
Oh, you locked in.
Lockdown.
I said locked in.
Oh.
Okay, we gotta move a little bit more quickly because we're already a little over the time I wanted to spend. We gotta get to probabilities today. A lot of us were thinking B or C. Why?
Huh?
A lot of us were thinking B or C on this one.
67.
I don't understand why you would think.
Yeah, why do you think that?
A lot of us put B, I think, if I remember correctly.
Cause she's short, right?
How do you know?
She said.
I would say this, she had to be shorter no matter what, just based on the answer choices. What do the answer choices tell us that Aaliyah has to be shorter?
There's 3 shorter and 2 taller.
Because all the percentiles are less than.
93.
Right. She's in the 93rd percentile, all these percentiles are shorter, right? So she had to be shorter.
That too.
Not that too. I understand your logic, but be careful. They can try to trick you like that. But yeah, like all those percentiles are shorter. Okay, but how are we supposed to figure out what this percentile is?
Draw it out.
Thank you. Right? Can I draw this crap out?
Yeah.
100%. Well, get over it. So there's one, right? It's just a hair less than one. And I just want y'all to think about it, right? There's multiple things you could do here, right? If we're looking for a percentile from that marker, what do we need to do? We need to shade some direction. We need to shade to the left. Lana, why is it to the left? It's in the name. Percentile is always to the left. If I see the word percentile, I am always thinking of what is left.
But why?
Huh? Because that's what a percentile is. Remember, percentile by definition is at or below. You gotta know that vocabulary. So it's percentile is at or below every time. Okay? Now, how can I find that area? There's two main ways. I could use calculator, I'm not gonna use,
Or you could just
Inverse.
look at it because it's already
It's
above
just a
67.
Yeah, you should.
probably, how do you know it's above 67?
Because it's not within one standard deviation. Because one standard deviation would just be like the middle part, and that's already that way, so it's 80.
So, you're kinda hitting at what I was gonna talk about. Notice, if it was from one below to one above, that's 68%, right? But we got more than just that, right? So it can't be 67%, it's gotta be more than 67%. Which only leaves you with D. But could, and I wouldn't use inverse normal, right? I don't have the area. Can you use the z-score though?
Yeah, I don't know.
And find the area between there using z-scores?
Yeah, but it's so close to 84.
I know, I'm just giving options, okay? If you're not comfortable with empirical rule, what I'm doing right now is giving you an option that can also work. So, a lower bound, pretty much anything super negative works, and then an upper bound of 0.96. It'll work. But I'm with Serena on this. That's essentially one standard deviation above the mean, right? Which means this region is half of what? 68. And then what's the left entire half always going to be?
50% or 50.
So what total percent is that? 84. We don't have full 84%, which is why it's 83rd percentile. Right? That's, again, the empirical rule can be really, really quick and useful, which is why we want to know the empirical rule, but you can use other strategies. Because you do, as you said, Michael, always have a calculator, but empirical rule could have sped that up significantly. Alright, I'm going to cover 13, but, yes, yeah. Alright, I mean, first off, guys, 14, oh my gosh, y'all broke my heart on this one. Okay, listen.
That was
Listen.
hard.
No, bro, no. Listen,
If you watch the YouTube videos, you
I
would
watched
know.
both of
Jaden,
your videos.
quit antagonizing her. Listen,
I didn't watch that.
listen, I know you didn't, shut up. She charges $12 an hour, right? So if she works 1 hour, how much money is she making? If she works 2 hours, 3 hours.
36.
So essentially what we're doing is we're multiplying everything by 12, right? Multiplication affects what? Measures of center, measures of spread, quartiles. You're the only thing a multiplier can't affect?
Minimum, maximum. I just shoot.
Shade.
I don't know what that's
Shape, but shape's not up here.
Standardized.
The whole point of a standardization, and this is why I said this earlier, remember, a standardized score is like the value minus the mean divided by standard deviation. But what else is it? It's a what in the distribution?
Wait, what's the question?
Marker. There's
It
an
is
L word used.
Location.
A standard deviation, or a z-score is a what? A
Location.
location in the distribution, right? It doesn't matter how I change the distribution, its location is going to stay the same. So yes, you are correct, Sprig, it would not affect the shape would stay the same, but notice that's not an option up here, but we're not going to affect the standardized score. Multipliers, do they affect the spread?
Yes.
Yes. Multipliers, do they affect the measures of center?
Yes.
Okay. Would it affect the first quartile?
Yes.
Like we're multiplying that value by 12, but the standardized score stays the same. Okay. Last and multiple choice. B is the value of a z-score of 1. Basically, guys, if you just did the percentiles, you're set. Third quartile, what percentile is that?
75.
75th.
Oh my gosh.
If you did a z-score of 1, we just looked at that, remember that was the 84th percentile.
Jake, it looks like you're.
It's like you're trying to dislocate something.
Okay, focusing on the stats stuff though, if you want to compare locations, there's two main things, z-scores and percentiles. The percentiles were the easier one to go to in this case, because we already had a 70th percentile, we already had a third quartile, 75th percentile, but that's why it was CAB, right, from least to greatest. E, okay? So percentiles and z-scores are locations. All right. All right. Hey guys, what's a median?
Middle.
50% split.
And it's the middle. And be careful that language of 50%. Because when we say, when I'm talking about the middle 50% of data, I could be talking about the IQR, right? Okay. But when I say the median, it separates the data into the bottom 50% and the top 50%. That's it. So if this is my cumulative relative frequency, the 50th percentile, that's it. For part B, that's the median, bottom 50% from top 50%. But I am going to have to talk here for a second about how to read this because most of us did not fully interpret this correctly. Okay? 450 followers, is that right? So 450 was here. What was her percentile? 40%. I had a lot of people talking about the number of followers was less than 450. That's not what the case is. She asked her followers how many, statistics teachers conducted a survey with her students at the beginning of the year. In the survey, she asked them to report how many followers they had on a certain social media site. So, 40% of who?
Students.
Of the statistics students. That's the 40%. 40% of the statistics students had what?
450 or less followers.
Had 450 or fewer followers. Now you should probably also refer somehow to Miriam, so had 450, so as many as Miriam or fewer followers, right? Like that's the idea of percentile. So 40% of the students had 450 or fewer followers. Remember, the variable is the number of followers. The students, though, are the individuals that we're talking about. Okay? Now, I'm going to move quickly through this one, because some of y'all are going to be a little irritated with yourselves in about 2 seconds. Most of us did pretty well here. Hey, but guys, if every ticket costs $12, right? Let's say that we sell 50 tickets. Every ticket costs $12. How much money did that person make? 600. How did you get that? So that was a multiplier. What do multipliers affect? Center and spread. Multiply by 12, multiply by 12, multiply by 12, and then that IQR of 80 multiplied by 12. So I don't remember what those numbers were off the top of my head. But all you had to do is multiply all of them by 12.
My
Okay.
keyboard kept on not clicking the keys correctly. It made me so mad.
Your calculator?
Yeah.
Grab a different calculator in that case. Alright,
Evil calculator.
what about in B? How's that $500 gonna affect things?
Everything's
Add
over
just the
measure
center.
It's only gonna affect the measure of center, right? Because every day gets $500, so is that gonna change the spread at all? No. So you're gonna take whatever your mean was here and add 500. Take whatever your median was here and add 500. Right? So what was the mean here? 2,300 something?
2358.
58? So 2858? Median
2400.
2,400 and 2,900. Make sure on actual AP exams you show a little bit of work to get there, but yeah. And so guys, please remember, when you convert things to z-scores, what's the mean?
0,
What's the standard deviation?
1.
That's the whole point of z-scores.
Yikes.
The mean is 0, the standard deviation is 1. Don't make your life harder than that.
show it work for that?
For C,
What work was there? You said the
there's no work, that's just explaining.
I mean, oh, okay.
Yeah.
Wait, like what, how would I explain it? Cause like I just put like,
0 and 1. Z-scores center the distribution at 0 and the standard deviation at 1. Just like, because like you can just guess that, but explaining that a z-score does that every time is your evidence.
So that paragraph right here was necessary?
It was or was not?
Was?
Yes.
Okay.
Okay. We gotta get probability. Last couple things. Right here, we should have been pretty good to go. Now, I want to talk about something, and I'm being very intentional about talking about this. This is not frivolous. I need you to pay attention to this. When you set this up, okay, the mean was 153. The standard deviation was 7.5. And so I actually changed this from what the original problem was because I did some research and I knew that the GRE quantitative reasoning could not have been right. I'll explain why in a second. So if you've never heard of the GRE, has anyone heard of the GRE? Yeah, I figured. Jaden, what's the GRE?
I forgot. And like, they would like jobs.
It's not jobs.
It's like the
Well, high
college
school.
exam.
It is the college version of the ACT. So if you want to go to graduate school, get a master's or a PhD or something like that, historically you've had to take the GRE. It's actually a significantly worse test than the ACT because there's very little correlation between your success in graduate school and your score on the GRE. But ignoring all of that, the GRE goes from a minimum of 130 to a max, first off, I don't know how they came up with these numbers, of 170, okay? So that's the quantitative reasoning, that's the math side of things, is 130 to 170. The qualitative, verbal reasoning is 130 to 170. What's the problem?
that's 175.
So what does that tell us about the distribution actually?
That the actual distribution isn't symmetrical.
Right, like, if we can't actually get here, if that's impossible, do we actually, and if it's not symmetrical, what else is it not?
It's not normal.
It's not normal. So all of this work we did here, it's actually impossible. Just want you to know.
So we should have gone all.
But, no, you did exactly what I wanted you to do. I left this on there for this reason to have this discussion. I need you to hear me clearly on this. If you can't satisfy the empirical rule, or if the distribution cannot satisfy the empirical rule, if it doesn't have 3 standard deviations either way, what is that distribution not? It's not normal. And that's important to understand. Can I still do z-scores if it's not normal?
No.
You can?
Because what is a z-score? It's just a,
Oh, standard
Standard
deviation.
deviation, how many?
well, it's just how many standard deviations. It's a location. Now, I cannot use the z-score to find percentiles and to find the proportion if it's not normal, but I can find a z-score. That's why I brought that up. It's like a z-score is a location. That is all a z-score is. But that location is useful when we have normal distributions, okay? Yes.
So with questions, like AP questions, try to trick us by saying like showing us that, like, the GRE goes from 130 to.
They, not to
170.
this, because there's no way for high school students to know that it goes up to a 170.
Yeah, but what if
But
they
they
give us?
could give you a
Right.
distribution for sure, and you would have to realize, like I've seen that on multiple choice, where you have to realize, wait, that would put this value into a negative. I think there's something about like bunny rabbits or whatever, and like their birth rates, and like I want to say the mean was like 7 a month or 7 a year. I don't remember what it was. Bunnies
my
have
goodness.
lots of
That's like a
babies.
lot, dang rabbit.
I don't think you understand how quickly.
That's why the
So
term
we're not-
is,
Yeah, like-
that's why there's a term,
No.
like
Yeah,
rabbits.
please, yes, please stop. Thank you for not friending. Anyways, it is, but something stupid like that. But then like the standard deviation was 5. Well, that means they could have a really long tail out to the right, but it can't go very far to the left. Well, because it's not a normal distribution. It was skewed right. Okay, so percent of GRE test takers between 145.5 and 168 came out to be 81.5%, because it's from 1 below to 2 above. Half of 95, half of 68, add them together.
What'd you say it was?
81.5%, because Sprague is going to go from 1 below to 2 above. So half of 68, half of 95. Right?
Wait,
So-
why? Half of 68.
So remember, that's 1 standard deviation. That's only half of that 1 standard deviation though, right? Because that's from 1 below to 1
I mean,
above.
could you not do 68 and then half of 95? No, that doesn't make sense.
So you can do it some of those ways. It's just easier, in my opinion, to just look at the left half, look at the right half. You can even just memorize smaller pieces of it. It's just easier that way. You can also just use the calculator, lower bound, upper bound. You just gotta make sure that you show some sketches. Bless you. Guys, please hear me clearly on this. You gotta show work with these things. You have to. It is simple as just drawing that normal distribution out though, and shading the right part that gives you credit. You gotta show some work though on the AP exam. Ms. Qualson's like, yep, I remember having to do that. It's true. So above a 140.5, again, this time you're gonna have to use a z-score because we don't have an integer number of standard deviations. And so value minus mean divided by standard deviation. I don't remember what that,
It was negative 1.6 repeating.
thank you, I knew it was something. Negative 1.6 repeating, so remember that's gonna be my lower bound. What's gonna be my upper bound?
Infinity.
Infinity, take 100, 1,000, whatever. So this was the lower bound of that shaded region, upper bound is something stupid big. And what's the mean?
0.9522.
No, what was the
Oh,
mean?
mean, I don't know.
0.
Like 153.
Oh, you're right.
0.
Standardized.
So remember, so Sprig, and everyone remember, the original mean was 153. But what did I do to get a z-score? I standardized it. The whole point of standardizing is so that we don't have to sweat the mean and the standard deviation, right? Once I standardize, I'm here, right? So I get that negative 1.6 repeating, and it's everything to the right. Setting up that z-score is another part of that credit for showing your work, so use that z-score to your advantage. And then part D, top 9%, once again, what am I gonna do? Draw. Top 9%, that's up here. And what am I instantly thinking of when I see that 9%?
Inverse.
Inverse, I see an area, 9%. That's the, here though. What do I actually need to put into the calculator? 0.91. Right, so inverse normal with that area, I think that z-score, did it come out to be 1.34 or something?
1.34.
Yeah, 1.34, yeah.
So there's your z-score, say equal to the value minus the mean divided by the standard deviation. Value minus the mean of 153 divided by the standard deviation of 7.5. Okay. Yes, sir.
What if we just plug into the calculator? How are we supposed to show that?
Don't. I know you're like, oh, that's so much work, whatever. One, it's not that much work. Two, the AP exam expects you to show understanding, not just plugging into a calculator, but showing understanding. So, drawing this can be a part of that evidence of understanding, okay? But get your z-score, set up the equation, and solve it. You can tell me, here's the thing y'all have to understand, and this is why I need us to clearly understand this. It doesn't matter what you know, it matters how much evidence you show the reader that you understand. That's what you gotta understand. And getting an answer right is not the same thing as showing the reader that you understand.
To be fair, I was late to class.
Huh?
To be fair, I was late to class, so I didn't bother to show any work.
Alright, so probability, so you got your DYUs back, hold on to them. We're getting into probability or more probability today. We're gonna talk about probability models, sample spaces, complementary events, Venn diagrams, unions, intersections, mutually exclusive events, disjoint events. The only thing we're really not getting into is independent events.
Oh my gosh.
This is probability.
Think we can knock that out in half an hour?
45 minutes, and yes sir, I do.
This is
Okay.
probability. This is not on the test stuff.
The probability is not on the test.
So
Oh, wait,
So
so
is it-
everything?
As a reminder, so the test will be on units 2A, or proficiency scales 2A and 2B. It starts from chapter 1 in the textbook, and it goes to chapter 2 in the textbook, because chapter 1 is our categorical and quantitative variables, and box plots, IQR, standard deviation, mean, median, all that stuff. Then chapter 2 was all of our percentiles, z-scores, normal distributions. But again, if you look at your proficiency scales, it's all on there. If you look at your Frere models, that's what walks you through the textbook. Don't forget, you have not turned in your normal distribution Frere model yet, so you need to do that.
So I'll basically
Tomorrow.
turn it off for tomorrow.
Correct.
Okay.
Yes, ma'am.
Before the test tomorrow, can we go over like
Joy, you
joint?
weren't gonna be here.
Remember, I'm quitting.
Oh,
Well,
Yeah,
I might
so
still go.
tomorrow-
You said you were still going.
What?
we'll figure it out. You can
But,
ask,
like joint, relative, conditional, and marginal. Can we go over that one more time tomorrow?
She's only saying that because she missed a question on her go. On her go.
how about this? If you wanna come before school, you can.
Okay.
I'll answer.
Wait, but I was gonna do the unit 1 thing tomorrow.
Before school?
Yeah.
Maybe ask me during advisory, because we need to start pretty quickly. But also like, sorry, I'm trying to think. Have you looked back in the book yet?
Yes.
/ watched the videos? Both of those, and you're still
I
got
haven't watched
questions?
the videos because I don't know which video it is.
It's weird. It's like it has a title to it.
Oh, it's almost like it's not in order, and I'm not looking through about 50
What?
videos.
Ooh.
Just look at his
the
most
playlist because there's only 12 of them.
Oh, are you sure? Because I feel like we've been in class more than 12 days.
Just look at his most recent videos.
The joint relative and marginal relative are
So-
not in the most recent
so,
videos.
I just want to remind you. So really quickly, there are 2 different playlists for class.
gonna win this
One
one.
is Unit 1 collecting data. That was 8 videos. And Unit 2 exploring one variable data is 13 videos. My bad. Now, I will remind you, it was at the very beginning of this unit, right? So if I go to the playlist videos, and I go all the way back to, I don't know, January 22nd or so, maybe 23rd, 24th, might be somewhere in there.
That was
Good
like a
job.
month ago.
Dang.
Tell them to live stream.
Ooga booga!
So,
Oh yeah.
Tell them you should live stream.
Yeah, actually.
I am still finalizing that. I'm trying to,
Can I get like an estimate?
I will say this, it's gonna be a longer test than we've had than the last one because it has 3 free response questions and it'll have 12 to 13-ish multiple choice. So it's
Maybe put
1.5 times the
multiple
length of the last one. Guys, we gotta get to probability.
Okay.
What, Michael?
What? How much time do we have with all of those combined?
Remember, it is 13 minutes per free response. It is 2.25 minutes per multiple choice. It is
Okay, I'll
the
bring us
scale
all
every
up.
time.
13 minutes per free response question. That's
Yes.
3.
39 minutes. Yes.
You can make it free.
Let's focus on that. The question's
No.
not serious.
That's
You
very
should-
tough.
Sorry.
You should
Sure.
definitely.
All right, I
Tell
need
Lexi.
somebody to join Jaden at his degree.
No.
Somebody else.
Go, Brady.
Go there. All right, we're gonna play a
Let's
game.
actually go to a different group though, just because
Oh,
of stuff
yeah.
there. So let's go over to the 8s.
Is it that serious?
Yes.
Well, it's more that we needed 4 groups, and we're gonna do 3 groups of 2 and a group of 3.
Are we gonna do that?
Huh?
Seriously?
What?
What is it?
No,
What's
I
it?
don't need this.
That's for you. If I don't get a pink one, I'm
All
gonna
right,
crash
do you guys
out.
have this
Crash
against
out
the
minute.
Imagine
Oh my
Starburst?
Yes.
Yes, no, maybe so. Get it out.
Stop looking at me.
Hey.
No, leave them in there.
I thought she said get them out.
No.
Are you teaching?
Did she not say get 'em out?
No.
She said get out your nose.
Oh, I'm just a girl.
Listen.
Yo, get out this.
Let's go.
Let's go.
Not pulling Starburst out. Getting out the activity.
There's like none in there.
Sweet Moses, huh?
You got it yesterday.
Got a yes, sir?
Looks just like that.
So we're gonna get it
Yes,
out?
thank you.
Yes, I have it right
Okay,
here.
perfect.
I have it out.
All right, I know we're all probably capable of reading instructions, but I'm gonna read it to you real quick. What you're gonna do, each of you, the game is simple. You're gonna pull a Starburst out, figure out what color it is, write that color down. Put it back in the bag, pull a new one out, write down that color. Okay? If you get the same color, you win. If you don't get the same color, you lose.
Gamble.
Each of you do it 10 times.
Each group, I think.
10.
Do you want more since,
Oh, 10 games?
no?
We don't have time.
Each group does it 10 times.
So we do it 5 times each?
You can,
You
one,
can
one.
do 10 for one person and 0 for the other. I don't care, just 10 per group.
Ready, set, go.
Okay, I'll pull it first, you pull it second. Okay, sorry, I'll pull it second.
You open the bag,
Is
pull out the
Right,
Starbucks.
tell me what's in the bag yet or no?
No,
Put it back in, I got
Don't
this.
look in the bag.
Wait, where do we write it down?
I pull out a red, I put it back
think on
in.
your paper.
shake it up,
Where am I?
pull another one.
Wow.
Wherever.
I'm in, okay.
So do, wait,
I got
so
another
I
red.
pull, try
No,
to.
I-
So I won because I got two of the same color.
2 times
So
is
what
Play
did
it
you
10
write
times.
down?
lost.
So play, write down
Wow.
red, or red,
You got the same color?
whatever,
You won.
right?
So
So-
is that 10 times?
And you're playing it 10 times, yeah.
Next to the people. Stop pulling out pink! Can we pull it out in a row, or we have to pull
Make
it
sure you
out?
shake it, or you,
Can we pull it out?
so one's one of you's pulling it,
Pull
and
it
then the
out,
other one's
put
pulling
it
the other
back,
one?
pull it out.
Okay, so no, take turn.
Okay.
Oh my god.
What are the chances?
You gotta put it back in.
Okay, I got
Yeah.
not
Okay,
right.
so
No,
shake
we're
it.
doing it very
Shake
good
it
by
up.
ourselves. I
Everyone
pulled, she's pulled pink 2 times, I pulled red 2 times.
Okay, I'm gonna pull red again.
So y'all did not win.
But pink's
Oh,
my color.
so, okay, it has to be wrong no matter who does
Yeah.
If I want red, you owe me soda. Oh. My bad.
No, so.
Do we only write it because it's the same color?
No, write down your combo every
Okay,
time.
come on, we gotta do something more time. Red? Oh, no, we're switching. Do I get pink again? Oh. I got pink! I got red.
Dude.
So,
How am I getting just red? What is just red? Is there just reds and pinks in here?
you have 3 pairs. Like,
There's just reds and pinks in here.
Oh, yeah.
Like, you pull it out.
What?
6 times.
There's only reds and pinks in here.
Okay, 8 is.
4 out of 10. What about the kings?
5 out of 10. Just one hand.
What about the 8s?
8 out of 10.
And 4s?
5 out of 10.
Converted for this one. They did.
You usually do like that.
Alright, perfect. Alright, so what were the number of wins for the entire class?
9.
22.
22.
22, yeah.
22 out of 4.
So 22.
Oh, my
So
God.
based on the results, what's the probability for the whole class that we win this game?
11 out of 20.
Just over 50%.
Let's just start with where it is, 22 out of 40, and
Yeah.
then that is equal to,
55%.
there you go, 11 out of 20 or 55%.
Alright, perfect. Cool. Oh, that's actually like almost exactly what they have on here. Pretty interesting.
I wonder how that happened.
Oh, wow. How could we improve the estimate, this estimate of the probability of winning?
Having more.
More repetition.
More people.
What's that called?
Sample.
Simulation.
Repetition.
There's a T word, it's more,
Trials.
there we go.
There we go.
So, replication, Spring, I'm glad you brought that word up. Remember, replication is literally more trials, right?
So that's like the same thing. You just
But,
ate all of them?
Yes, I ate 3.
hey, replication though is in a reference to what major idea?
Experiment.
Experiment. So, this was not an experiment, so I wouldn't call this replication.
What
It's
is
just more
this?
trials. Probability?
Yeah, but what is it?
Probability.
Why is this not an experiment?
Well, are we looking for cause and effect?
Cause grabby shovels.
No cause and effect, no treatments, right?
Yeah.
Yeah, you're not changing anything.
Alright,
Yes. Also the law of large numbers.
you ready for the next one?
Yeah.
Say that one, oh yeah, please make sure you have that note down, guys. Please notice, how do we get closer to the true probability of winning or get a better estimate?
Having more trials.
Having more trials because of the what?
Law
Law of large numbers. What does that mean though?
The more numbers. Like, you're more likely to have an accurate estimate of
Yeah.
something if, like, you try it, like, 50, 100 times than just, like, trying it twice.
That's true, let's get more precise with our definition from a stats perspective.
As the number of trials
Do you
increases,
want it?
the actual value approaches the expected value.
So, as the number of trials increases, the relative frequency approaches the true probability. So the relative frequency of success approaches the true probability. Okay? That's what we mean. Remember, in the short term with the basketball thing, it was super variable, did not always hit the 80% free throw shooting, but in the long run, it did. Okay?
Alright. Gonna anybody have a guess on what was in the bag?
without having opened it.
Yeah, unless you cheated.
Well, at first I thought it was just one pink and then the rest red.
You got one pink and the rest red?
Yeah, that was like 4 reds and 3 pinks maybe, I don't know.
Oh, cool. There were
Big little feet.
4 reds.
Yeah, you can open it now.
Yeah.
Okay.
Wow.
I didn't
I was
count how
like,
many there were,
when
I
I-
just ate.
Oh, you just ate them all? Well, there were 4 red and 2 pink, and Serena said, I want all of them.
Wait,
we had 3
was that for
pink.
every single one like this?
I got mine from the bag.
Yeah.
What the heck?
They were all like that.
I got like the
Yes.
last one in there.
So it was on purpose.
Yes, it was very intentional.
Nice.
Would it have been a good study if I gave different people different conditions?
Yeah.
There's always variability.
Well, no.
Yeah, there's variability in what you
So there was
draw.
like
Yeah.
no pinks in the bag.
Yeah, I was really bummed. Not
Are we
gonna
gonna get to like the
That's where you have to
side
get
of
the
this,
fave
like,
reds,
numbers?
because they have the best flavors.
So what was that, insert?
Bro, red is
I
not
got
the
the
best.
basket.
No, fave reds has like
Right
pinks
here.
and
The
lime.
red
Stats.
Red is one of the best.
And all that stops now so that we can learn statistics.
Okay. Have you guys ever seen a table like this before with probability?
Yeah.
Maybe in like
Yeah.
8th grade?
Not probably.
It makes me
Looks like a
think of
punch
the
square.
bean
Yeah.
things.
Okay. Very similar. So,
What
Punnett square.
Punnett square.
we're gonna fill out this table. What goes here?
RR.
That just
Got a
means and by the way, I do want to point out, like, if you look along the sides, that's why we always label things. On the left side, it says first for first drawn candy, and along the top, it says second candy, right? So what we're saying is that the first drawn candy is red, the second drawn candy is red. That's why RR, okay?
RR.
Alright. Same thing. You first draw a red, then you draw another red. A red, then another red. A red, then another red. What about now?
Red mark.
Red
A
and
red, then a pink.
Red and pink.
Red and a pink. Alright.
That's first.
Y'all get the gist of this? Fill out the table.
Oh my god.
That's a lot of filling out.
It's a lot of complaining.
No, no, it's not complaining, I'm just saying it's a lot
Oh.
of filling out, that's just a statement.
Hey y'all,
Yes, sir?
fill out your table, not you, Serena and Jaden, who are trying to trade Starburst that they can easily do after class and not distract.
But he's gonna eat them by then.
You're
You're talking like you're not gonna eat yours, dude.
You're right.
Wait, Pete.
Hello?
Ah, that's so funny.
Oh, you did not just say that. No, you ain't
Yeah,
there.
it's not like.
Fill out your table.
This
Great.
is how you
I
What?
This is
I
how
was
you know
just-
you-
He's and ours look too similar.
I
Well,
Well, it wasn't an
tell ya.
experiment though.
Yeah, should show the
Operational study. I was looking for association.
Alright, whatever.
Why would you choose the best flavors?
So what was the point of being like yellow? Just so we.
Orange is the best.
Well, it wouldn't
And
give
then,
it would be different.
Alright, perfect.
You like Taco Bell.
If I finish this
Okay,
table,
so
y'all
now
have
everybody
to
get it. Okay?
Are we gonna do 1, 2, 3 eyes on me right now?
Yes,
Yes,
ma'am.
ma'am.
Thank
What was it?
Alright, so, this right here, what we just filled out, does anyone know what that's called?
Punnett square.
A probability table or something.
This is our sample space.
Oh.
Close, real close, you guys are right there.
Sample space.
Okay, that makes it way easier.
Thanks, Gangalicious.
I can't.
Gosh.
That's not red.
Pardon?
Thank you, but this is easier to see versus the pink, is it not?
Do we actually
I was gonna say, nobody
Do
can.
you want us to do that?
Alright, so, we kind of circled the outcomes that are both red. What is the probability of winning with 2 red?
Wait, really quickly, sorry, just to clarify, what do we mean by sample space?
This-
What's wrong with that?
Huh?
All the possible outcomes?
Say again?
Is it all the possible outcomes?
It's every possible outcome. When we say sample space, it is listing out every possible outcome, every possible what we call event. Okay? So it's every possible outcome.
Alright, so, Circle the outcomes with both red. What is the probability of winning with 2 red?
16 out of 36.
16 out of 36.
I was gonna say
I
that.
said it faster.
Okay, it doesn't matter who said it when. We said it. Perfect.
We got the idea.
We get it. Alright, what is that? What's the decimal?
Do we have calculators?
Oh, wait.
Oh, we both, right?
I was 32. That's not bad.
Are you okay?
Okay, so, hey, can anybody think of another way instead of just counting that the probability of getting red first and it's just and red second, yeah?
Yep.
I have a paper right in front of me, actually. And second, red. Instead of counting these squares, going 1, 2, 3, 4.
16.
Yeah,
16.
4 nights.
4 times
4
4.
times 4, yeah.
4 times 4, right? Because it's
4 reds.
a
Yeah.
square, 4 times 4.
Boom.
So we get 4 out of what though?
Out of 36.
Well, hold on, she hasn't even done the 4 times 4 yet, we're gonna get there, 4 out of what?
9.
Why are we thinking 9?
4 out of 6.
I did 2/3 times
6,
2/3.
right?
know what these are.
4 of our 6
Oh.
are red, and 4 of our 6 are red. So 4 6 times 4 6. What does that equal?
16 over 36.
26.
So, hey.
Oh my
Oh,
God.
I only ate 2. They're so innovative. Citrusy. Now my mouth hurts.
I hate
Oh. It said yellow. I was like, what? We use pink.
Yeah, because they're better.
Wrong. Anyway, back to the
He will eat
statistics.
taco costumes.
Alright,
Don't take
statistics.
What's the probability of winning with 2 yellow?
14.
Pink, sorry.
4 out of 36.
Oh my gosh.
4 out of
He
36.
really wants to know.
What's that decimal? Hey Jaden, what's this decimal?
I don't have a calculator.
It's like,
Have that.
but it's not like, it's like 1 over 9.
So now we have the probability of pink first and second pink. How are we gonna do that?
Yeah.
Just 2 times 2?
2 over 6 times 2 over 6.
2 over 6 times 2 over 6, which gives us?
I will. Second is a good question for everybody.
I'm gonna be guilty, boy. No, you.
Lana was
And this
asking
is
why you're
amazing.
writing that inside of parentheses.
So this is like the notation for probability. There are quick note slide on the back, we're gonna go into that. But this P is probability and then of whatever is written inside of here. So sort of like if you have like function notation, it's f of x, same thing. The probability of whatever we have written down.
We will learn more shorthand notation that even simplifies it further, but it's a way to tell someone the probability you're calculating.
So overall, what is the probability of winning? What? How do you do that? We add them, right?
Hooray.
So we have,
This is getting low. Okay.
can you guys see
Get
this?
down low.
Even?
Yes.
Can I get that?
16 out of 36 plus 4 over 36 gives us what?
20 over 36.
Now, if I were writing this the same way here, so the probability of win red, should I put and here, or is there something else that goes here? Or, right? Or win pink. Ugh. Hurt my knees. So does anybody see a connection with the and the or and what we did? What is it?
You can't win both red and pink.
I think Ms. Qualsey's trying to go
Probably
talk
asking
about
Ms.
the
Qualsey.
mathematical operation.
Yeah.
Oh.
Union?
Why would it's and?
That's not an operation.
When we used and, what operation did we use?
Addition. Multiply?
Yep.
When we used
Oh,
and,
Oh, multiplication.
we multiplied.
Yes.
And then when we used or,
We added, right?
we added. Good job.
Which is 55.5.
Yeah.
What?
Serena,
What?
your last name's Klein, right?
Yeah.
She needs you for your book.
Yes.
Why?
I don't know.
You're so
Yeah.
Don't
stable.
ask me. Okay, perfect.
It's the thing you're looking for. Like, if the thing you're looking for is a number, like if I'm rolling a die, what's the probability of rolling a 5? The probability of 5. So it depends on what your variable is. Okay.
We good?
Yeah.
Okay. Can I erase this?
Yeah.
Everyone got it?
Yeah.
Online, still right.
Oh, wait.
I got it.
Okay.
Wait.
Wait, can we please?
Okay.
Like I'm begging.
Try what?
Wait, wait.
Wait.
I don't
Second.
have any more.
It's gone.
Why
It is gone.
right?
Because I want pink and I gave them all like a student.
Look how sad he is.
I know.
I'll trade you for yellow.
Nobody wants
Oh,
your
It
yellow.
has pink. They're gone.
I have pink. No, I'm trading.
He's being nice to you. He's being nice to you.
I need 2 yellows. 2 yellows.
I'm fine. I don't
Oh,
care.
3 yellows.
No.
2.5 yellows.
No.
2 yellows. 2 yellows. 2 yellows.
It is
Hey.
not capitalism, you guys.
Oh.
Okay, good.
Economics
No,
class
I
paid
was
off.
trying to think.
This is not AP macro.
2 red.
You got it.
Oh man, I was trying to hit Jay. There's no more red.
Yellow?
Good.
Yep.
There's
Alright.
yellow.
Hello.
Guys, right here.
Okay.
Wait, see what's real?
Hey, Jaden,
Wait, look at you distracting.
what's up?
Your face is on.
You wanna?
What?
What?
So, talk about split that in half. Oh, I was just wondering if we were gonna focus in real quick. That's all.
Lock in, Jaden.
You
Lock
can hang
in.
out. You can hang out with me if you want to. All right. So what is the sample space?
All the possible, outcomes of that.
Yeah. List of all possible outcomes. All possible outcomes. So the probability. Alright, so the probability of an event happening, we're going to use E. That is the number of outcomes in E in the event we're looking for. Sorry, I don't know how to spell. What's it going to be over? Total outcomes in sample space.
I can't believe you didn't know my last name. I'm a celebrity now, guys.
What was that about?
Wow.
It was an interview for STEM Club, Jaden. You know the club that we went to meet for once?
Technically, we're still
That still
returning that.
exists?
Technically.
So,
Does it
in order to use
They got
what?
one
Does
on
it say
these.
of outcomes in E? Is that what it says?
Yeah, outcomes in E. So like in this event we're looking for, the total number of outcomes in that.
Oh yeah, I talked about you.
So does anyone know when this can't be used?
When you have, without replacement?
Without replacement, yes. When the outcomes are not equally likely. So this is only used, all outcomes must be equally likely. Cool?
So yes, with the without replacement because they're not equally likely, but also like when we're talking about shooting the basketball, is it equally likely that you make the basketball as you miss it?
No.
No.
It depends on the
You,
skill.
you
Well,
get
it
better.
depends on the skill, right?
Wait.
So, but we're talking about Ms. Gallus from that first lesson. She was an 80% free throw shooter, right? So, is it just her outcomes of success divided by total possible outcomes?
It's like confounding, kind of.
Be careful again. Confounding goes to the idea of
I
causation,
know, but I'm
and
saying
we're not.
I'm not saying it is confounding. I'm saying it's
So,
like the
like, confounding-
probability portion of confounding.
As
I just
confounding
wouldn't
is
use
experience.
that term there. Let's
I'm not
do
gonna use it
that.
on an AP
So
exam.
what was the probability of us winning this game? What did we say our probability was?
55%. 55.
Oh wait, probabilities are always under 1 though, so like 0.55.
There we go. That's a good
You're so
note.
smart.
5, repeating, right? Whatever.
So please note the percent of times you would win in the long run is 55.5%.
We write down the second.
But the
You write down
probability
the
is
second.
0.555 that you win once.
This is just an example.
Okay.
So what would be the probability that we lose?
Opposite.
Point
0.4555.
4.5 roughly.
How do you get that?
It's just 1 minus the probability of it happening.
It's 1 minus
It's a fair flavor.
0.555 repeating, which is like 0.45555 repeating roughly. So, what do we think the complement rule is?
Really quickly, I do want to point this out just because I heard Sprague say this earlier. Be careful. I know the term we normally think of is opposite, but the word opposite in math really only means like the opposite of 5 is -5, the opposite of -7 is 7. We don't call it the opposite, we call it the,
Always picking on me just for saying, well, it's complement.
I'm trying to help us learn good language. Even the idea of inverse would not be 100% correct here because the idea of an inverse mathematically is the input so like the input was z-score, the output was area. The inverse is the input is area, the output is the z-score. For inverses, the inputs and outputs switch. That's not what we're doing here. It's a complement, okay? Which is what Jaden was saying. It is.
It's the base formula, so.
No, stop. That comes up later. It ain't Bayes' formula.
Oh.
That's what I'm saying.
What is the complement? What did we
Sorry.
literally just do, Jaden?
Huh? Of the probability of it happening and not happening together is what?
What is the complement rule? How do we find a complement?
1 minus the other number. One number.
Yeah, so the probability of any event's complement is 1 minus the probability of that event. So that's what we did here, okay? A win complement is a loss. You lose. Okay? That make sense?
Yes, ma'am.
Both equal.
Hooray!
So probability of event not happening. Of event not happening.
So what's the A mean?
Just any event. We could use W here,
For
if
win.
that helps for win, like I did over there. But just A is just any event. Sort of like here, E was any event, it's just a new notation. So, now we're gonna work on the probability of A and B, what that notation looks like, and probability of A or B,
What is B?
any event. So in our case,
Any
this would be
different
our,
event.
any two
Oh.
different events. So this is our A, this is our B, this is our A, this is our
Oh,
B.
yep.
Alright?
Yeah.
I'm gonna write it under there in a second so you can see it. But, so for and, we have probability of A and B. Probability of A or B.
Brother.
Yeah, union,
Which one's the union?
Second one.
Or
the one that,
Do you know what
It's
this
like
one
a
is?
U.
it's
no,
the opposite, so when you like subtract data set or something like that, or
No, onion. Trust.
Oh, we don't have,
union.
Whatever
You
union back
learn
is.
this.
Wait, hold on.
Y'all probably didn't. Y'all learned unions when you
Algebra
did
2.
domain and range. Oh, you
Oh,
would
yeah,
have
we
done
did do
algebra
that.
two
No, I
with
Didn't it?
inequalities. Yep,
Oh, okay, that.
like forever
I was
now.
confused.
that union.
Yeah, there's different ones.
Yeah, like a union.
They actually mean
Compare
the
it.
same thing
Oh, it's
in
like
math
a
and
line
probability.
So what does it mean? It's not like you can, like
It means or one thing.
No, like
or
what is
the
it?
other.
What is it?
Oh, the
Intersection.
Oh, okay.
Sorry.
Basically,
So, probability of A and B, which is probability of A intersection B, this little symbol, that means both of them occur. So that's what happened here. The probability of red first, I'm gonna erase these. Red, I'm just gonna write red one, like that. And red second, right? And then this one, the probability of when red or when pink. So, with and, that means both of them happen, okay? With or, you could have one happen, you could have the other happen, or both of them happen. Okay, we're gonna show it in a Venn diagram. Is that like next? Perfect.
Wait, so this all events? Wouldn't that just be like 100%?
So, can I see the note? Where's the?
I don't know, you
It's
have
like,
So,
if it's
remember,
10% of every.
Like, think about it this way. The probability of winning was probability of 2 reds or 2 pinks, right?
Mhm.
I guess it was actually
Which point number
Your raffles.
Mine was really
Right there.
good,
But is that
no,
everything?
Yeah, I was really
This,
outside.
or this,
I
yeah,
was
there's
the one right
options outside of that.
Oh,
So what Michael's asking is a good question, but
oh, you
notice
say-
the union is not everything.
I think I have.
Because there can be stuff outside of the 2 events that you're looking at.
You should pick candy. I've had enough candy.
Yeah, I was like, we had enough candy today.
Oh, what are those? Outside.
What is like thing?
Don't worry about it right now. Technically, it'd be the complement, right? If it's everything outside of it, it's a complement. But don't sweat that right now. It's just not what you're interested in, I should say. Okay. That's it, right?
Yeah, that was all of it. So,
Yeah.
yeah.
Sorry, I'm trying to think.
Do we want to show the diagram?
Yeah, that's kind of what I want right now.
Yeah.
Hey guys, I want y'all to attempt the check your understanding tonight for, well, you'll have a test tomorrow.
Yeah.
How about this? We
I have
will,
two tests tomorrow.
well, listen, we'll start tomorrow with the check your understanding for the bell ringer, okay, for after the test. Frick, we have a test tomorrow.
That was lineup.
We should just.
You got-
Let's just do this part quickly together, and then we'll do the
I
Venn
know. Are you
diagram.
working with?
What Venn diagram?
Are we gonna do the Venn diagram stuff?
Yeah, I know, we got this. Alright, so guys, let's talk through this probability. Part A here, Stephen, so Pew Research reported that family size is shrinking. Suppose we were to randomly select one mother and record the number of children. Here's a probability model. Stephen argues that the probability of a mother having exactly 2 children is 1/4 because there are 4 categories. Explain why this is incorrect.
What?
Oh, wait, okay.
Because
1/4.
Because
We're not all equally
Stephen-
likely.
That was not equal.
There are 2 major reasons you could say here.
most people.
0.24.
Cause it's 4
Jaden,
plus.
what did you
first of
say?
all.
They're not all equally likely?
Why?
Well, you
Well,
can.
they don't all equal 25.
Yeah, 1 is 22.
Yeah, all has to
3
equal
is
to 1, right?
24.
So-
4 plus is 13.
So,
Like, give you just stupid.
y'all are all right. Jaden had a really big one, but I need y'all to hear what Michael said. Say it again,
It
Michael.
doesn't equal 1.
What does the probability have to add up to?
1.
Uno.
It has to add all the way up to 1, right? So not equally likely. Doesn't add up to
So
1.
that'd be like 0.25. That's.
So what is the probability of having exactly 2 children?
Oh,
What by one?
Like,
Zero-
it's about
0.141.
0.51?
I thought you
Oh, wait,
divided.
I just really zero,
I
right?
thought you used 1 and then minus.
How did we do it?
0.59.
1 minus
0.22
0.22
plus 0.24 plus
minus
0.13.
minus.
So
one.
1 minus, well not minus 1, 1
41.
minus.
Yeah.
Oh, 0.4.
41?
Yeah,
Well,
yeah,
zero point
0.41.
Yeah,
0.41.
0.41. Don't say 41. It is not 41. Those are 2 completely
Yes,
different
ma'am.
numbers.
It's gotta be something between 0 and 1. I will point out, we essentially just used what kind of rule?
I said 0.41.
Say it louder. It has to add up to what? 1, complement there, okay? You got 3 problems left, I need y'all to do that for homework. Sorry. We gotta do this really quickly.
Can I write that real quick? Oh god. What is the?
Uh, Yeah, pause for the sake of the repeater, because
These
that's
look
not
like
correct.
clocks.
What?
They have
Thank you.
0.41. Thank
Hey guys,
Pardon?
so, I just want y'all to see what Peter instantly started doing. Peter, look at this Venn diagram, it's a great mistake, learn from it, don't be upsetting. So, he said the probability of A is this. I told him that's wrong, why is that wrong?
everything in the circle.
In what
2
circle?
sides of
The,
it.
Where is
A circle. A
A
circle.
So it's all of this.
Peter.
So that entire
God.
circle is A, right?
On your test.
Hey, that's not necessary.
Well, she came.
Do you want us to color it? I did.
It's true, y'all do come for each other. Okay?
Hello?
Y'all come for each other all the time, how
What
about
do we
it?
each shade in for B?
All of B.
Sit
All of
down.
B,
Yeah,
wow.
but dirty
I know
guy.
you're sitting down, but sit down more.
Bad.
What about A, compliment?
You shaded like all of these. Like, I don't.
Well, is it only the
Try shading all of B, what do we see?
Like,
They
it
overlap.
goes B there, so it's just.
It can
Only
be
the part of B that's
compliment.
not A.
Yeah.
Only the part of B that's not A, right?
Wow.
It's the complement of A.
I understand now.
That's not A.
Yeah, let's add that.
I was
Yeah,
gonna say, are we doing,
Yeah, we need to.
so,
Technically, you'll notice that,
If there's more.
yeah, Ms. Kowalski's putting, so the entire sample space is inside of a rectangle technically. Because remember how Michael asked this earlier? He said, what about the, that would be, or you talked about the union is everything, right?
Yeah.
But wasn't there stuff outside of the union?
Oh,
Of
yeah,
Two
yeah,
reds and two pinks? So we always put it inside of rectangles. And so when we say not A, it could be inside that rectangle and not be B either. So I'm glad Ms. Kowalski.
So you want some
reminded us of that.
rectangle color?
This just
around
feels
it?
like we're
Yes.
drawing like the
I'm
middle.
like-
Basically, it's a
so what about the
bunch
probability of A intersection B?
Just the
The
middle.
middle.
Just the middle, where they intersect, super easy to see on a Venn diagram. That's what this, yeah, this is what these are called. What about A, union B?
Everything but the middle?
Like everything?
No.
No,
Only
it's
the inside.
So A and B, but not the part where they're touching.
No.
I gotta touch it.
So
Yes,
you want
the part
A
where
and B,
they're-
but not this middle?
No,
I don't
No,
know.
Yeah.
In the middle, right?
So remember, A or B is A, or it's B, or it is,
Union,
Both.
because they're married.
yeah.
Perfect. What about A, union B, complement?
Everything.
Not the
Literally
circles.
everything but the circles.
Everything but the circles.
Ah.
Because it's the union, but it's the complement of that union. So it's not the union.
My brain hurts.
Exactly right, you got it.
I promise it'll get easier once you work with
So
it.
it's the wedding
For the starter, the
party.
problem, the A union B wouldn't be the ones in the middle, right? You just have those, right?
How much for your
So the
pinks?
A union
How much for your
B,
pinks?
the probability
I want
of
it.
winning is 2 reds or 2 blue. Oh, I see what, hey, so Jane's asking a good question. He's saying it's not the middle, right? Because if we're looking at the starburst problem, the probability of, the first outcome of winning was 2 reds, right?
Yeah.
Whoops.
Yeah.
And then the second one was 2 pinks. But do they overlap?
No.
No, that's actually gonna be an important part of tomorrow. That is what we call, what type of events?
Independent.
Mutually destroyed.
Mutually
Oh,
exclusive.
mutually
or
exclusive
disjoint.
or destroyed.
Independent is later, but those are mutually exclusive. They are independent or disjoint events, not independent events. Golly.
Get it right.
I did. All
Long day.
right. What do y'all got tomorrow?
Yes.
Do you and Miss Moore just like plan and make the test?
Yeah, we talked and we just want to like,
You guys
man,
just
I'm gonna make those Cal kids' lives as difficult as possible.
Really? Yeah.
Okay, come on.
I know.
Jump on, there we go.
No, they are that
Go
tight.
I was like, I looked at it.
You have Rory playing.
And I was like,
That
would be one. No.
You have it already playing. Huh?
Which one?
Oh, they told me
Do you have it for real already playing?
Already been thinking
No,
about
I mean,
this.
seriously.
Like,
Yeah.
I know.
I got
I
you.
was like, wait, I have it right here.
Look at Peter hogging all the pink starbursts.
Like a-
Hey, Peter, you-
There's a reason why I can't play